In this lecture we're going to discuss the Pythagorean theorem, proportional relationships, and polygons. So we'll start with the Pythagorean theorem. I'm sure you guys have seen this several times in your math careers. A squared plus b squared equals c squared, and this is for all right triangles and only for right triangles. And another way to think of it is leg squared plus leg squared equals hypotenuse squared. So the way to find the legs on a triangle, guys, and make sure you pay attention here, is the legs of a triangle are the two sides of the triangle that are adjacent to or that touch the right angle, and the side opposite the right angle is the hypotenuse, which is on a squared plus b squared equals c squared. The two legs are your a and your b, and the hypotenuse is your c. So here's a visualization of the Pythagorean theorem with crackers. I don't take credit for this. I found this on Google Images. But you see this right triangle here. This side of the triangle is 3, and 3 squared is 9. This leg of the triangle is 4, and 4 squared is 16. And supposedly a leg squared plus a leg squared should equal the hypotenuse squared. Well, when we draw a square off that hypotenuse, you'll see there's 25 crackers there, and 9 plus 16 is 25. So the leg squared plus the leg squared is the hypotenuse squared. Now let's just do some real basic problems with the Pythagorean theorem. We're supposed to find the value of c using the Pythagorean theorem. So let's find this c. Well, the first thing you have to notice is the c is the hypotenuse in this diagram. So this is a leg and this is a leg. So leg squared plus leg squared equals hypotenuse squared. And my hypotenuse in this case is c. 6 squared is 36. 8 squared is 8 times 8, which is 64, equals c squared. So we get 100 equals c squared. Now that doesn't tell me what c is, that tells me what c squared is. And I bet you remember from algebra, the way to solve a problem that has c squared and you need to find out what c is you take the square root of it to get rid of the squared. So the square root of c squared is c, but if you take the square root of one side of the equation, you have to do the square root of the other side, and the square root of 100 is 10. So c equals 10. Now let's see if that makes sense visually. It does. The hypotenuse should be the longest side of the triangle. Now take a look at this one. It says we're supposed to find the value of a using the Pythagorean theorem. And notice that a is not the hypotenuse. A is a leg. So here we go. Leg squared plus leg squared equals hypotenuse squared. So we get a squared plus 5 squared means 5 times 5, which is 25. 13 squared is 169. Now we use a little algebra to solve this. We subtract 25 from both sides of the equation, and we're left with a squared on this side of the equation and 140. Let's see, I put minus 25 is what I meant to put there. And we're left with 144 on this side of the equation. And to get rid of our squared, we take the square root of both sides. So we get a equals 12. So the leg of this triangle is 12. So we have a 5, 12, 13 triangle there. Here's an application of the Pythagorean theorem. Let's read through this. Lexi and Danny were hiking in the Black Hills. They started at the same point, and Danny hiked 4 miles north while Lexi hiked 6.2 miles east. Let me grab my pen here. So let's say they start right here, and here is Lexi. No, this is Danny. She went 4.1 miles north, so she's right here. And Lexi started at the same place as Danny, and she went 6.2 miles east. So this is Lexi here. Now, we want to know, let's keep reading. They found out that their cell phones will only reach each other if they are within 7.5 miles of each other. Will they be able to call each other? Well, they are now this far apart. So I'm going to put an X here because we want to know how far apart they are. And since one went directly north and one went directly east, that's definitely a right angle, which makes this a right triangle. And we're looking for the hypotenuse of this triangle. So we go leg squared plus leg squared equals hypotenuse squared. I'm going to bring my calculator up and we will solve this problem. So I need to find out what 4.1 squared is. That's 16.81. So I have 16.81 plus, now I have to take 6.2 squared. 6.2 squared is 38.44. 38.44. And that equals x squared. So now we'd combine my 16.81 with my 38.44. So I have to add 16.81 to this. And that gives me 55.25. So 55.25 equals x squared. And now we need to take the square root of 55.25. Let's see, there it is. And that's 7.43 approximately. So x is about 7.43. That means they'd be able to call each other because they're about 7.43 miles apart, and there's an application of the Pythagorean theorem. Okay, let's talk about polygons. Polygons is just a simple closed plane figure consisting of only line segments, and the endpoints of an edge are called a vertex. So this is a vertex, this is a vertex, this is called an edge. If it was circular or an arc, it would not be a polygon. They have to be made up of line segments. And all three of these are regular polygons. Regular polygons mean all the sides are congruent, so those all have the same length. The stop sign is an example of a regular octagon. This one is a regular pentagon because all 5 sides are equal. Some more things on polygons is the sum of the interior angles of a polygon. You can find that using that equation there, 180 times n minus 2. Now here's why that equation works. We've learned earlier in this chapter that these 3 angles in the triangle add up to 180, right? Now let me draw another segment here. These 3 triangles add up to 180, and these 3 angles add up to 180. So notice there's 3 triangles inside that 5-sided figure. So we take 180, and then that 5-sided figure, when I subtract 2 from it, that gave us our 3 triangles. 1, 2, 3, and that 3 I take times 180 to give me 540 degrees. So those 3 angles add up to 540 degrees. So whenever you have to find an angle inside of a regular polygon, or the sum of the interior angles, you use that formula there, 180 times n minus 2, and I showed you why it works, because you just split it into a bunch of triangles inside the polygon. Okay, this says find the measure of the indicated angle. So we need to find the measure of this angle right here. Well, this is a stop sign, which is a regular octagon. So let's first take 180 times 8 minus 2, which is 180 times 6, and I believe that gives us 1080. So there's 1080 degrees when you add up all 8 of these angles, but the question says to find the measure of one of those angles. So we're going to divide that by 8 to find out the measure of one of those angles. That would give us, let's see, 8 to 28 is 135 degrees. Every one of these interior angles measures 135 degrees, and visually that looks right, so I have confidence in that answer. I'm trying to think, on my math lab they'll have questions on Pythagorean theorem and on polygons, and then also on similar figures where you use proportion. So here's some proportional reasoning for you. I want you to look at this problem here, and even though a lot of you can do it in your head, let me tell you what some students do. They'll say, oh, 8 is 8 smaller than 6, 16 is 8 larger than 8, so I'm going to add 8 to this 3 to get 11 up here. Because they say, oh, it's 8 larger to get from here to here, so I'm going to add 8 to 3 to get 11. That is not proportional reasoning. That is not the correct way to do it. A better way to think of it is to go from 8 to 16, I doubled this length. So if these are truly similar figures, then if I double one side of the figure, I need to double the other side. So this would be 6 inches. And that's proportional reasoning. Now, the way to solve this, let me put an x here. And do you agree with this? I could say x over 16. In other words, this small side over this big side equals this small side over this big side. So 3 over 8. And then to solve proportions, we've done this earlier this year. You cross multiply and we get 8x equals 48. So x equals 6. So that's how you could do it if you couldn't do it in your head. Here's another set of similar figures here. So these are called quadrilaterals. They're four-sided figures. And we've got to find what? We've got to find side HE. Well, here's HE. We don't know the length of that side, so I'm going to put an X here. Now there's some information here I don't need, but what I do need is this. These two numbers in red, and then let me go to a different color, and these two numbers, I believe that's green. So, do you agree I can do this? 10 over 12 equals x over 8. In other words, red over red equals green over green, and I stayed in the same order. In other words, this side corresponds to this side, so notice the 10 and the x are both on the top. This side corresponds to this side, notice both of those are on the bottom. Okay, when we cross multiply, I get 12x equals 8 times 10, which is 80. So now I divide both sides by 12 to solve that, and I get x equals, and 80 divided by 12. I should be able to do that in my head. It's going to be 6 point, it's actually going to be 6.6 repeating, 6.6666 I believe. So about 6 and 2, that'd be x equals 6 2/3 if we change it to a fraction, or you could just say approximately 6.67. Alright, I believe we're going to do one or two more problems. If you look at these figures, are they similar? Well, you'll find out on my math lab and by reading chapter 10 in the book. Figures are similar if they have two angles that are congruent. And notice we have a triangle with a right angle, so this has a 90-degree angle and so does this, and this triangle has a 55-degree angle and so does this. So these are similar triangles, but they're not really set up to where it makes it easy to set up a proportion. So what we're going to do is this, if it lets me. There we go. We're going to twist that one just a little bit, and we're going to twist this one about 180 degrees like that, and now we have them both situated kind of in the same format, and we can, let's do this. I'm going to circle this in whatever that color is, we'll say gray, and this in red. So I go gray over gray, in other words x over 6 equals 10 over 15. Once again, the x corresponds to the 10 and the 6 corresponds to the 15. So I stayed in the correct order there. So I get, when I cross multiply, 15x equals 6 times 10, which is 60. And when I divide both sides by 15, I get x equals 4. Okay, that's a little bit on Pythagorean theorem, proportional relationships, and also on a little bit on polygons. So that should help you on my math lab, and good luck with that. Goodbye.